Okay, good morning, everyone. So welcome to our first module on Azure Machine Learning. So if you have any questions during this course, feel free to give a react or raise your hand. So let me first introduce myself. Okay, let me just So let me first introduce myself. My name is Ziggy Zulweta. I'm a 6 times Microsoft Azure certified engineer. So I hold in AI, I hold two certifications. One is Azure AI Fundamentals, and another is Azure AI Engineer. So I'll be discussing actually the first certification, which you can actually gun for after you complete the series of courses that I'll be providing. So the agenda for today would be as follows. So I'll give you a brief introduction on what Azure AI is all about. So all the different features of Azure AI. And then from there, I will be discussing machine learning. So we'll be discussing what supervised machine learning is versus unsupervised machine learning. And then from there, we'll discuss the different, the three basic machine learning classifications. One would be linear regression, classification, and then clustering. And then from there, we'll actually have two exercises. So to get your hands dirty. So the first one would be creating an Azure account. So if you don't have one, I'll teach you on how to create one. So there's a free Azure account with $200 credit that you will be using throughout the whole course. And then from there, we'll create a workspace that you can use all your uh, machine learning jobs later. And then from there, we'll do an exercise on linear regression. And then from there, I'll actually introduce you to um, an automated machine learning feature of Azure as well. So what is Azure AI? So actually, if you look at it, a lot of people know AI and I mean, they always accustom it to ChatGPT. But if you look at it, ChatGPT is just one aspect of AI. So AI is actually a broad concept. So here you can see the different areas where AI is, and then how Azure would actually uh, meet those requirements. So somebody's joining. Okay. So in Azure AI, you have the areas of machine learning. So examples of that would be linear regression, classification, and clustering. So we'll be discussing those three later in the course. So then we have language in the field of AI. So in language, you have translations. So imagine me speaking now in English, and then we have an AI translation that will translate to the different languages automatically. You have analyzing text, in which you provide the text and it will analyze what is the summary of that text. Language understanding would be similar to what Alexa would provide, wherein you give a command to the device and then it will understand what the command is. Question and answering and chatbots are related, wherein you have these chatbots wherein you ask a question and then the chatbot will reply based on the data that's given to it. Speech recognition would be, in terms of speech, you have speech recognition, wherein you convert the speech to text. So, for example, those transcription tools that you see, wherein I'm talking and then you see the text based on on what I'm saying. And then speech synthesis would be converting text to speech. So imagine that you have a chatbot talking to you in natural language. And then speech translation, as it implies, would be translating whatever it is that I'm speaking right now to a different language. Then you have vision, wherein you have image analysis. So you provide Azure an image and it will describe it for you. For example, you give a lady shopping in a supermarket, it will describe that and it will tell you if it's buying something or not. Video analysis would be analyzing video, then reading text from documents and images. So let's say I have a contract in PDF file, and then I'll upload it in Azure, and it will give you the necessary necessary text and images. Object detection would be an example would be in a traffic situation wherein it will count the number of cars. So it's detecting the number of cars. That's the object. So facial detection and facial recognition are related. So facial detection will detect faces, and then facial recognition will determine who that person is. And then when it comes to decision, you have anomaly detection, wherein it detects anomalies in an environment. So for example, you have a production line wherein normally it's giving out a certain output, but all of a sudden it gives a different output altogether. So that's an anomaly. Then content safety would be, for example, us talking, and then if somebody says a bad word, then the system will automatically omit the bad word. And then personalization would be, for example, in a shopping cart, those typical Amazon websites that you see wherein it personalizes based on your past um, purchases. And then knowledge mining would be uh, putting all of your data into a knowledge store, and then using AI search, it will be able to detect all the different information that you have. Now, when it comes to certifications, there's actually a lot of certifications you can get from Azure. So I'll introduce you to Azure AI Fundamentals. So this is the starting point for those business people or developers or anyone actually. So you don't need to be a developer to actually get this certification. So with this course, you are measured against your ability to know the different artificial intelligence concepts that I discussed earlier. So being able to detect which one you actually need, and then from there, it also asks if you have fundamental principles on machine learning, which today we'll be discussing, on computer vision and natural language processing. So let's go on with the course. So what is machine learning? So it's actually a technique that uses mathematics and statistics to create a model that can predict unknown values. So it's a way of defining a function. Let's call it function of x. Wherein going to algebra. So imagine, so if you recall your high school days, so you have this line y is equal to x plus 1. So y is actually the label. So that's your result. X are the features. So these are the variables. So imagine that I plotted a table here. We're in for x of 1, y is 2, x is 3, y is 4. So that's actually easy to solve, no? Because you're actually having one variable, and then you can solve for y, no? But the question now is, how do you solve y if there are a lot of variables? If you have y is equal to a, b, c, d, e, all the way to x, z, or a million variables, no? So you can actually, if you recall your algebra days, you could probably solve this with just two or three variables. But when you go higher up the ladder, it's practically going to be impossible already for you, and will take a lot of time. So this is where machine learning comes into play. So once you have 10 to 100 different variables, that's where machines will be able to help you solve the equation. And later we'll be discussing why you even need to have to know this now. So we'll discuss different use cases for you. So in machine learning, there are actually two types. There's a supervised and unsupervised. So the supervised machine learning is practically having a data set with known label values. So for example, in this equation, z is equal to a, b, c, and d, a plus b plus c plus d. You know, a, b, c, and d are all known. So you already know those. So for example, let's say you have a business situation wherein you're selling a certain product, and you know all the variables, but you don't know which variables are actually having an effect on your sales. Okay. Now, for unsupervised machine learning, the issue here is that you don't know the result. No, you have the variables, but the results are unknown. Okay. Sorry, I made a mistake here. So let me just fix this slide here. Okay. So scenario. Hold on, somebody just joined. So going back to the scenario, for supervised, you already have a past data set. So I made a sale of Z because these were for today it was a Monday. So that's letter A. So that's your variable. It was a Monday, and then letter B was time of the day, for example. Letter C was you did a promotion, and letter D would be, for example, say it was a holiday, no? So now you're trying to determine in the system that if it's a holiday, if I make a sale, if I do a promo, etc., and on a Tuesday, what would be the Z? No, what would be my sale? For unsupervised machine learning, Z is unknown. In other words, you have all of these variables, but you don't know the result. So you're just practically giving the system information, and then you just let the system decide if there's a relationship or not. So those are the different. That's the difference between supervised and unsupervised machine learning. Okay, somebody just joined again. Okay. So in supervised machine learning, you have two types. No, first is regression. So in regression, you're using you needed to predict a continuous value. So let's say a price, a sales total, or some other measure. So in other words, you're trying to understand the relationships between the variables and the outcome. So for example, um, in a house, no. So let's say you want to create a system to determine the price of a house, and then your variables would be the square footage, the number of rooms, the location, for example, if there's a promo or whatnot. No, so you have a system to try to predict home prices. Another one would be on farm conditions. So you have weather, soil quality. You can add in, for example, humidity, temperature, if it rains or not, and then from there you actually predict crop yield. Another one would be on the past campaign. So based on advertising logs, you'll be able to predict future advertisement clicks. No? So that's linear regression, in which we'll be having a what do you call this, lab exercise on that. Next would be unsupervised machine learning. So in this one, imagine that you have different data points, and then you're trying to determine if there's actually a classification. You can group them together. So there are two types. So one would be binary, wherein you want to determine. Wait, sorry, here going back, we skipped one. So in classification, you want to predict if there are different types of classes. So for example, in this case here, you're trying to clump the circle class from the triangle class. So this is a binary class label wherein you have two different classifications. So for example, whether the patient is diabetic or not. So in the example here, you have clinical data, and you have the specific patient with a different huge number of variables. For example, a lot of blood tests that the person has taken, a lot of blood tests, and then you put in all the history, and then from there determine if that person is diabetic or not. So that's a binary class label, yes or no. So there's a multi-class as well. So for example, I provide a text data, and then from there it will determine if it's a positive sentiment, if it's a negative, or neutral. And then another case would be in a loan application in the bank. So the company will give X number of variables from sales, revenue, income, and all of that. And then it will determine if it's a pass or a fail when it comes to providing a loan. So that's a classification supervised machine learning. And it's supervised because you're going to train the system based on past variables. So for example, in the bank, this is our policy. So if a certain client has this and that in the variables, so for example, the sales is less than 5,000, um, debt is this much, etc., etc. And then from there, we normally give it a failure, for example. And then from there, you put it in the system, and then that's how the system will learn and will solve future problems for you. Now, for unsupervised machine learning, it's actually different. So you don't know the result. So for example, in this case, let's say you just input all of these data points in the system, and then the system will try to determine for you if there's actually a relationship. So in this case, it was able to find that there's a blue group, there's a red group, and a green group. So, uh, but you initially did not know it, no? So you just provided the system these data, and then the system, using unsupervised machine learning, was able to get that. So, in other words, you train a model to separate items into clusters based purely on their characteristics or features. Okay. So, for example, one would be customer attribute data into segments for marketing analysis. So, for example, you provide the system that honestly don't know what the relationships are, but you just provided the system that these are your typical customers. So the age, the weight, the height, the race, for example, the sex, the educational background, for example, and then that person bought this much, but you don't know the relationship, so just input it in the system, and then from there, the system will just tell you that this is your customer groups, no? So those are the three that I mentioned. So there's regression, there's classification, and clustering. Now let's talk about Azure Machine Learning. So Azure Machine Learning is actually, if you look at it, those machine learnings that I discussed earlier, you can actually do it in your laptop. So actually, in pre-pandemic, I was actually already learning AI, and then during the pandemic, I had a lot of time in my hands. I started doing machine learning in my laptop. And the thing was, my laptop, even though it was high powered, it took let's say 5 hours just to solve a problem. Because imagine that you're solving a problem with 10 or more variables. It needs a lot of computational power. So if you're doing it in your laptop, you don't know if the solution that you have is correct, and you'll have to wait for 5 to 10 hours just to see if the answer is correct. No? So that's where Azure Machine Learning will come into play, because from here you're going to be using somebody else's resources, because your laptop isn't that powerful. You're going to be using high-powered servers to solve the problem for you. So what would take 5 to 10 hours to compute would take minutes in Azure, because you are renting out, quote unquote, the computational power that they have. So before I delve into that, let me just go through quickly the three basic concepts. No, so first would be the learning workspace, and then the studio and the compute. So what are these three? So the first step that you normally would do is to create a workspace. So this workspace would manage your data, your compute resources, the code, and the models. So it's just a think of it as a bag wherein you put all the different resources that you need to go, no? And then from there you use the learning studio. So this is actually a drag and drop feature that we have in Azure, wherein even though you do not have any development experience, you'll be able to prepare data, train models, and publish predictive services. So this number two is where we will actually delve in later. And then number three would be the compute. So as I mentioned earlier, you may have your laptop and you can solve problems in your laptop, but your laptop isn't a high-powered machine. So Azure Machine Learning Compute is where you will use all the different high-powered compute resources of Azure to solve the problems for you very quickly. So by the way, if you have any questions, feel free to raise a hand, and then or ask any question in the chat, and then I'll try to answer them as we move forward. So in terms of Azure Machine Learning Compute, there are actually four types. So I'll just go through it quickly. So you have the instance. So this compute instance would be basically having one machine. So like imagine that you have one laptop in the in the in the cloud, but it's one high-powered virtual machine. So this normally if you're doing basic machine learning tasks, the compute cluster would be many virtual machines. So for example, in the case that I was doing preparing for this course, I needed a cluster because I'm processing many tasks at the same time. I'm solving 5 different problems at the same time. So you would need a cluster for that. So for example, oh, I made it. If you're using a compute instance, let's say you run a job and then you make a mistake, you need to wait for the job to finish. No? For the cluster, you can have 100 jobs running at the same time because you're practically having many virtual machines running in parallel. The inference cluster would be once you create a model and you deploy it on production, this is where it will come in. And then attached compute would be if you have existing compute resource already. So this for more advanced, the attached compute. Okay, so let's go to our first lab. No? So in our first lab, um, most of you are probably new or do not have an Azure free account. So we'll create a free account for you in order for you to use your $200 free credit. And then the second one would be to create a workspace. So uh, I'll be sharing this lab exercise to you in the chat. Okay. Okay. So I'll just go quickly through the lab. No? So first you need to create an Azure account. So if you go to Microsoft Bing or Google, just search Azure free account. And then from here, you'll see this link to create your Azure free account, wherein when you click on it, you'll go into this website and you click on here, the start free. So once you click start free, if you do not have an Azure account yet, you need to create one here and just follow the steps that you need to actually complete one. It will ask you for a credit card, but don't worry, it will not charge you. So it's just there to verify that it's a new account. And then from there, once you get an account, from there you'll be able to have $200 for free, which we'll be using for the whole entire course. In fact, we will not be using the whole 200, in which for further explorations you can actually use that. So just follow the instructions quickly on that. So it's actually in the Word document. And then from there, we'll create a workspace. So the workspace would be the final result would be this one. So yeah, I'll give you around 20 minutes to complete that lab exercise so that we can create our linear regression exercise after. Okay, go ahead. If you have any questions, feel free to ask them in the chat. So for those who need guidance, so let me actually do it also in parallel. So once you create your account, you need to go to portal.azure.com. So that's the link that I provided in the document. So actually, I have a lot of things going on around here, but for you, you'll just see one subscription with your free account, in which when you click on the subscription, uh, you'll see that actually nothing's there now. But from here in the home page, okay. So in the home page, you'll be able to create your resource group. So from here, just create a resource group. So in this case, I will put here um, my first resource group, for example. And then from here, you'll go to Southeast Asia. So this is where I'm located, nearby. So then review and create, and then create. So once you've created it, so this is my first resource group, I'll create an Azure Machine Learning resource. So in the marketplace, I'll search machine learning. And then from there, create Azure Machine Learning. So from here, I'll just put any value. So this is my first machine learning workspace. Okay. Then I'll put Southeast Asia again. And then from here, I'll leave everything in the default. Okay. So click on review and create, and then create. So that's it. So that's the lab. So that's as easy as you can get when it comes to creating resource. So just wait for around 3 minutes for the deployment to be completed, and then you're done. So this would be uh, the first lab. So we have here, you can also do this in your spare time if you're not able to do it right now. So first one would be to create your free account. So if you don't have one yet, and then from there, go to portalazure.com, click resource group, create one, and then from there you create the resource. So which I just demoed earlier. So wait for the deployment to be completed. Okay, so let's see, is it complete already? So it's not yet. So there, it's completed already. I click go to resource. So from here, I will see Launch Studio. So the Azure Machine Learning Studio. Click on this Launch Studio. And then from there, you'll go to your first Azure Machine Learning Studio here. Okay. Okay. Uh, just a raise of hands. Was there anyone here able to do the lab? Any questions, any problems that you have encountered? Let us know in the chat box. So we'll continue on in the next 5 minutes. So there's one person who asked, "Do you need to input your credit card?" Yes, you need to do so because it's a way to verify uniqueness. Because there are some people, which me, for example, I tried to create multiple accounts because after my $200 credit was finished, I tried to create another account with another email, but I used the same credit card. And then from there, the system did not allow me anymore because I've already used up the free credits that I had. No, so that's how they verify the uniqueness. So in other words, if I needed to create another free account, I needed to use another credit card. So I had to use somebody else's credit card just to get the free credits again. So that's how it is in Azure. So it had to be done because if Azure did not do it that way, then a lot of people would have abused the free credits already. And it obviously it is a business, so I mean they need to have a business, so they can't just provide free credits all the time. So it's okay if you're not able to create your resource. So you can all I'll share the recording of this session um, as we move after this session. So I did a demo on how you can create the resource. So let's continue on in the interest of time because we have a lot more topics to cover. So once you've set up your workspace, so once you've set up your free account and then create your workspace, the final result would be here, no? So you have your Azure Machine Learning Studio. So this Machine Learning Studio is where the magic happens. So you don't need to be a developer, which I'll be showing you later, for you to solve all your machine learning problems. You just need to go through this studio. Sorry, I'm not sharing a screen. Thank you for that. Okay. Okay, so going back again. So after you created your free account, and then you've created your workspace, the next step would be to go to your Machine Learning Studio. So this is where the magic happens. Uh, you don't need to be a developer. So this studio is a drag and drop feature wherein with just a click of a button, you'll be able to create your different tasks in Azure Machine Learning. So before I continue, there are four basic steps that you need to understand. First one is if you want to do any Azure machine learning task, you need to prepare your data. So you need to identify the features and the label. So features again would be your variables, and then the label would be your result. And then from there in Azure, you need to pre-process it. You need to clean and transform it and do all the necessary tasks if needed. So for example, let me just give an example here. Um, so I have downloaded this Excel file from the internet. Actually, I just typed in Google or in Microsoft Bing free machine learning Excel worksheets, and then from there it provided me a so I'll share this also. Let me share this to you guys so that you can see this. Copy link to the sheet. Okay, let me share this to you in the chat. Okay, let me put this in the chat box. Link. Okay, share it again. So so this will be your homework if you want to do extra work later after this course, no? So in this worksheet, you have the different variables. So you have fixed acidity, you have volatile acidity, citric acid. So I'm not a wine connoisseur, so I don't know honestly what these variables are. But you have residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH level, sulfates, alcohol content. And then from there, these are the quality variables, the quality result. So the first columns A to K are all your features. Okay, so that's the features that I'm mentioning here. Label would be the result. So in this case, in our example, the result would be the quality. So that's what we are actually trying to look for. So this is actually around 4,900, rows. So in other words, this is what, in layman's term, this was the past data in the business. No, so in a business scenario, this can be your different business variables. No, so since we are in a supervised machine learning, you're gonna train the system that this is my past scenario. In the future, if you have a new wine that comes out with these variables, what would be the quality? Okay. So in this one, you don't have a system yet. So this was the past data, and then this was the result, but you don't know the relationships between all of these to the actual result. So now you're going to have the system determine that, okay, based on these in the future, what would be my result? So that's what we're actually gunning for. So that's preparing the data. And then from there, the second step would be training it. So when training, you need to understand that you need to have a training set and a validation set. The training set would be to train the system, and the validation is once you have a trained model, you need to validate it against your existing data. So normally, the split here would be 80-20 or 70-30. When I say that 70% would be your training, so you train your model based on 70% of the data, and then once you have a model in place, you validate it against the remaining 30%. And then from there, you evaluate. So for example, if you're able in machine learning, you there's a term called R squared, which we'll discuss later, wherein if based on the trained model and you validated it and it's higher than 90% or 95%, then you're in the business accepts that 5% failure, then you actually have a model already in place. And then from there, you deploy it in production for production purposes. Okay. So I'll go through quickly. I'll guide you to how we do it now. So in the first step, in preparing the data, you need to load it and then you need to clean it. I'll discuss what normalization is, and then joining tables. This one will not discuss because we're having just one table. So in the Azure Machine Learning Studio, so you have this data part here. So just go to the Machine Learning Studio. So this is your Machine Learning Studio. So you can see a lot of different tabs here in the left. So you have here the data asset. So for example, what I'll do is I have this wine quality Excel worksheet. So I downloaded it here in my documents. Okay. So I have it here. And then from there, what I'll do is I'll go to data, then I'll click create. So from here, I'll put sample data. And then from here, I'll choose file. So that's easy as that. And then click next. And in data source, I will choose from local files. And from here, I'll just ignore this. I'll just accept the default. And then from here, I'll upload the file. And then click on next. Then create. So there. So the data has been uploaded, and then you can actually explore to see if it has been um, uploaded. No? So the result that you should be getting is that one. So that's that. Okay. So next one. So once you've uploaded the data, the next step would be preparing your compute cluster. So again, as I mentioned earlier, um, by the way, just to put a note here for future reference. When you have a file that you want to when you have a file that you want to put online, you need to make sure that your column names do not have spaces. So just a quick input on that, because for some reason the system will always have a failure eventually if you continue on with the exercises. So For columns like this, you need to put an underscore after. So just the only thing that I want to put a note here. So now, once you've uploaded your data, you'll prepare your compute. So again, this compute is the computational power that you'll need. These are the different machines that you'll be using. So let me just show you how you do it. So you need to create a compute cluster for our exercise. So from here, so we've done our data. We go to the compute. Okay, and then here in compute, so you see the 4 different compute scenarios that I mentioned earlier. You click on compute cluster, and I'll create a new one. Okay, so from here, I'll have a dedicated virtual machine. All of these I'll just ignore. I'll just put in the default. And then from here, I click select from all options, and I'll search for a virtual machine name. So I'm choosing a cheap one. So this one here, but it has actually 6 cores available. So I'll choose this one, click next. I'll put a sample compute name. Okay, and then I'll set this nodes to 2. So it means that I'll have 2 cores. Okay, then create. And then from there, I have practically a resource already online that you can use. So these are high-powered machines that I can use already at my disposal. And then from there, what will happen is I'll create my first pipeline. So what is this pipeline? Pipeline is basically, which I'll show you later, is a different set of steps that the system will produce. No? So let's go here to designer, and I'll create a new pipeline. So this pipeline, so let's put here a name. So sample pipeline. Okay. So in here, the first thing you need to do is to upload your data. So actually, I have here the wine data that I uploaded earlier. So you can explore it. So let's preview data. So this is what it will look like now. So everything that I showed earlier here in the sheet is now here. Okay. So as you notice, we're just dragging and dropping. So we're getting all the different components and just dragging it. But for the lab exercise, which I shared to you, so lab number 2. So I'll actually go through lab number 2 with you. So in lab number 2, if you click on this link here, so in the lab, it will actually create a workspace. You're needed to create a workspace, which you did in lab 1 already. So the create compute you need to do. And then from there, we have different steps that you will do. So I'll go through this quickly for you before I turn this over to you guys for the lab. So in the lab exercise, we're not going to be using this wine quality data. So that wine quality data, which I shared to you, you will use that for your homework if you want to do it. If you want to do additional work on the side, no. So for our lab exercise, we're going to be using the automobile data that we have from Azure. So Azure, if you look at the data, Azure here has a lot of data sets that you can work with on the fly. So on your extra time, if you want to work on other machine learning tasks, they have a lot of data sets. You have a weather data set, a CRM data set, flight delays data, etc. Wikipedia, animal images, etc. So animal images would be next week in our machine learning. If you want to do, if you want to join us, I'll teach you how to do computer vision. No? So in our exercise, we're going to be using our automobile data. So I'll just drag that here. So in this automobile data, if you preview it, you'll see a lot of variables. Actually, this is around 26. Symboling, normal. I'm not a uh, car enthusiast, so I honestly don't know everything here. But what this scenario here tells you is that based on these variables from make, fuel type, aspiration, wheelbase, engine location, length, width, height, curb weight, and all of these different factors, this is the price of the car. Okay, and this is 26 different variables. So obviously, if you try to solve this on your own through by hand, it's actually practically impossible to create an equation on 26 variables to determine the price of the car. And actually, the thing here is that we don't even know. That's the beauty of machine learning. Um, you don't know if there's a relationship between bore and price, for example. You don't know if there's a relationship between engine size and price. So some people may say, "Oh, I know it," but the thing is with machine learning, it's supposed to determine for you if based on these variables there's a relationship or not. It will tell you. So that's the beauty of what AI would do for you, because you may have a preconceived notion, but you don't know that based on the AI algorithm, the system has provided that for you. Okay. So now, as you can see, I can click on the different variables here. Um, One thing I want you to look at is that in the future, when you're working on these data sets, you need to look at missing values. You don't want to have missing values, a lot of missing values in your data set. So for example, going back here in the previous column, if you go to normalized losses, you'll see that you have a lot of missing values, around 41 missing values. In other words, you have 41 rows with missing values of this. So if you put this in your system, and you have a lot of missing values, it will affect your model. So what you should do is that you will remove this. So you'll have Azure remove this for you. So that's the first thing you need to look at. So you need to look at each and every column, and if there's a lot of what do you call this, missing values, you need to remove them in the system. So for example, in our exercise, bore had 4 missing values, so we'll remove it now. So that's Uh, so here we uploaded our sample data, and then from there we need to observe the data. So look for missing data. So you need to remove them, and then from there you need to have a you see that the data has different scales. So what do I mean by different scales? So if you look at it here, your symboling column is in the low digits, okay? And then your wheelbase is around 80 to 100. So that's 100 times the symboling. And then from here, you'll see that length is nearly 200. You have curb weight is around 2,000 to 3,000 range. Engine size is 100 to 150. And then bore and stroke is in the low figures, low single digits as well. So all of these are in a different scale. So, and then you have peak RPM here, high, 5,000. So price, obviously, you ignore that because that's the result. So what I'm trying to say here is that your variable should be in one scale. You need to, that's how you call normalization. So that's those are the things that we need to do. So the first one is to clean the data, and then to normalize them for that so that they're all in one scale, which we'll show later. No, so when you say one scale, it's all going to be in, let's say, in a scale of 0 to 1, for example, all of them, so that when you make a equation, nothing is um, if you don't, for example, do normalization, the peak RPM with the highest value will affect the whole model because it has the higher value. Okay, so what we should do is this should be the result in the exercise. So once we've uploaded the data, we'll select all the columns. In which case we'll remove our normalized losses. So let's do it. Let's do it already on the fly for you guys. So as I mentioned, we chose the automobile data, and then from there we need to select the columns that you want. So search here, select columns in dataset. So we just drag and drop, and then from here I drag the output to the input, and then from there I click on this. So double click, edit column. So search by column name. I'll add all, but I will remove the normalized losses. So again, no, we removed the normalized losses because we saw that it had um, so many missing columns that it will affect the whole model. So might as well remove it altogether. So click on save. So from here, let's say I'll put information. So removing normalized losses. So once I've selected all the columns that I need, what I'll do is I will clean the data. So as mentioned earlier, there are some columns. So by the way, in the lab exercise, I also have here this text to help you, to guide you. Okay. So I add the automobile price data. I select the columns. So I'll remove the normalized losses and then I'll clean the missing data. So in the exercise, we were able to determine that stroke, bore, and horsepower had some missing columns. So I want to remove, but what I'll do is I'll do a rule wherein if it's missing, I'll remove the entire row altogether. Okay, because I don't want to affect my model as well. So I want to have, in order, it's a garbage in, garbage out. So imagine if you have so many missing columns, let 40 plus in the scenario that I showed you earlier, it will affect the model. And then from here, I also want to remove also the rows. So from here, edit column, I just put in stroke, bore, horsepower, click on enter, then save. What will happen is in the cleaning mode here, I'll say remove the entire row. Okay, then click on save. Okay, so I'll put in here node information. So remove bore, stroke, and horsepower. And then from here, drag this to that. So what happens here is I uploaded automobile data. And then from here, in that automobile data, which I showed earlier, so you can, again, you can explore it by previewing it here. So here we see that when you clicked on this, normalized losses had 41 missing values. I want to remove that altogether. Okay. By the way, in our data, we have 205 rows and 26 columns. Okay, so in the 205, we have practically 41 of them missing. So it's practically 25% of your data set. So it will affect your whole model altogether. So we need to remove it. So we removed the normalized losses, and then from there you cleaned it, in which we made a rule wherein bore, stroke, and horsepower. You look at those columns. What will happen is, if it's missing, remove the entire row altogether. Okay, because it will affect the system. And then afterwards, we need to normalize. So in normalization, so as we mentioned earlier, when you preview this again, so all of these data, the symboling, all of these numbers are in a different scale, no? So obviously for the text, we ignore them, but for these, we need to put them in one scale altogether. So going back to the sheet here, all of this. So we need to normalize symboling, wheelbase, length, width, height. So just copy this here. Click on this. So columns to transform, click on edit column, and then from there, put in this list, enter, then save. So transformation z-score. So I'll not go into that, but it's a method, statistical method to normalize everything into one scale. And I'll put here normalize columns. All right, and then I'll drag it here. Okay, so this is actually the first step, preparing the data. So from here, once I run this, so let me just give you so let me just save this first, by the way. So I have an example here of a run. So this automobile, I selected it. So this what will happen, no? So if you look at once I run this, here's the result that will happen. You can see that the normalized columns was already removed. And then from here, clean missing data. From 205 rows, if I click on it and I preview the clean data set, from 205 rows, it became 199 rows. And then from here, normalized data, if I preview it, what will happen is all my data, so this one, the symboling, The wheelbase, the length, width, height, the system adjusted it. Notice that they're all on the same scale already. Okay. So that's what we actually did. Okay. So let's go back to designer. Let's go back to our sample pipeline. So once you've normalized the data, what will happen here is now we need to train the model. So in training the model, you need to choose what algorithm will use. And then from there, you need to split the data. So as I mentioned earlier, once you split, you want 70% for training and 30% for validation. And then you train the model. Okay, so this should be the result that should happen. So here quickly, you need to first choose your model. So I'll choose linear regression. Okay, let's put that here. And next, I'll split the data. Drag it here. So in the notes, when splitting the data, I want 70% training, and then I put a random seed. Random seed is like a random number generator. So you want to have a specific random number generator so that in the future, once you replicate it, it always uses the same random number generator. The problem is if you don't choose one and the system tries different random number generators all the time, you might have different results. Okay, so from here, I click on this, random seed 1, 2, 3, and I'll put 70% of my um, data set to be for training. Okay, so 70% training data. Okay, and then from there, I will train my model. So drag this here. So here you have two data sets. So the first data set, this one here, I'll upload it here in this data set. This next data set, again, if you recall, this is the one that we'll use for evaluation later. So for this one, I will train. So using linear regression, I will train the data using 70% of the model. In training, you need to put here the label. So we're training for price. If you recall, you have many columns there, but the price is what we want. Now make sure that you are using this case sensitive. So if it shows here price, so compute for price. Okay. So let's go back now. Let's go back here to the automobile price data, preview. Make sure that, okay, here price is all small caps. So this is what we're going to be computing for. Okay, so it's in the same so okay, price, okay, same. Okay, so that's what you need to be looking for. So once you've done your training, the next step would be evaluating the performance. Okay, so in this case, we need to evaluate um, so actually, this is the result that will happen. No? So eventually, the system will score it, and then based on the price that you have, this is what the system um, computed for, and then it will determine the result. So let's do that, and then I'll show you how it happened in the run. So I train it, and then from there I'll score it for model. Okay. So remember, when you score, you need to base it on the trained model and the split data here, the remaining 30%. Okay. And then from there, I evaluate. And that's about it. So once this is done, hopefully everything is working fine here. You create a new experiment. So sample automobile experiment. So I'll now train the system. Okay. Sorry, I'll create new sample automobile experiment. Okay. Click on next. Right. Now here in the runtime settings, make sure that you select the compute that you use. So let's say I'll use this compute, and then next I'll submit. So now what we just did here was that we created a model, okay, and then we're training using this data. We're now gonna create a model to compete for future data. So this will take 7 minutes. So this is the actual result that you should be getting. So let's go here to what I showed you earlier. So this was the actual result that you should be getting. So in this example, we loaded the data. We selected only we selected all columns but removed the normalized losses because again, the example earlier, we had 41 columns that were 41 rows that were missing. So we had to remove it. And then we cleaned the data because there are some columns with missing data. And then from there, we normalized everything, in which I showed you the result. It was all in one scale. And then from there, we split it. So this, if you want to see the result, so in your first data set, we've split it. Remember, there are around 200. So 139 would be on the split, on the first split. And then we have around 60 for the validation. And then from there, we did a training. So we trained the system. And then from there, we scored it. So let's say this was gonna happen. After we scored it, so again, no, we score it based on the validation set. So we trained it against the first 140, and based on the trained model, we validated on the remaining 60 rows, and this was the result. Based on that, um, this was the price in our data. This is what the system got. Okay, so from there, as you can see, for this one, it did not accurately get it, but for this one, it's okay. It's near. This one obviously did not. So from here, we evaluate. No, we evaluate the result. So using statistical data. So I'll not go to this because it will take a long time to discuss what mean absolute error and all of these statistical data is. But normally, what people would use is the coefficient of determination. So this is your R squared, in which case the system, what this data is telling you is that based on our model, it's 91% confident that it will be able to determine the price for you. So this is what you tell your customer, that based on the data that you provided me, based on our first run, we have a model we're in with 91%, 91.77% accuracy. This is how the system will accurately determine the price. No? So from here, remember we ran our so this is the one. Oh, it's already completed. Wait, is it? Yeah, so it was very quick for me because I already ran a similar exercise. But for you, it will take 7 minutes to complete it because this is going to be your very first run. No? So so from there, after we've run it, so we have a model already. We deploy it now in production. So from here, there's actually some steps that you need to be doing. So obviously, you can't use this in production. This one they created earlier. So you cannot use this in production, obviously, because you had already this data set given to you. Okay. So what we'll do is this one, instead of once you trained a model already, this one should be an unknown variable. And then from there, you need to do the steps. So for example, in the future, I have some data that I will upload in the system. I will I will remove the normalized loss. I'll clean, and then I will do the necessary computation for me to get the price. So this how it will happen. So if you go to your pipeline, so in the sample pipeline we created, from here you create a real-time inference pipeline. So again, as I mentioned, this automobile, you will not need it anymore because this is the one that we used for our training. So from here, enter data manually. So that's what's going to happen in the future. Someone will manually enter the data, or there will be a web service input. Okay, so those are the two scenarios. Um, so from here, when you enter data manually, so we're going to enter data manually. In this case, we'll specify some sample data. So just copy and paste this here. So this will be in the exercise. So just copy and paste that and then click on save. Okay. Then afterwards, remember when you have a web input or you enter the data manually, in our example earlier when we were training, we included the price. But in the future, once we go in production, so let's put this a production pipeline. So remember in our training earlier, you had the price, but normally in production, you don't know the price. So you're inputting the unknowns, the variables that you know, but you don't know the price. So in this case, we need to remove here the price, because once you go into production, we're actually having the system configure the price. So it's no longer there when you enter your variables. So in production, you'll enter all of these 25 different variables, but the price you will not upload because you're trying to have the system computed. So remove it here in the model. Okay, then click on save. So that's the step here. So we added this enter data manually, and then we edited this data set. And then from here, this actually not necessarily, but let's do it anyway. So we want to execute a script. So in our script, if you recall earlier, the answer of the result of score model would be scored prices, no? But this one we want to change it to predicted price. So if you go here, we just copy and paste this Python script. So from scored label, so the system had scored label as a result. You want to change the name to predicted price. So that's practically what the Python script would do. In addition, we want to remove the evaluate model, because we are no longer evaluating in production. We already know that it's 91% accurate. So remove that. It's no longer needed. So from here, we execute a Python script. Okay, let's put that here. Remove this. Okay, drag here, and then this Python script, just delete this and then paste this one. So make sure it's in this format. There should be no additional spaces. Okay. All right, no spaces and then no additional. So if there's a space here like that, it will come out an error. So you need to make sure that there are no spaces here. If there's an additional tab as well, it will come out as an error. Okay, so you need to make sure that they are aligned like that way. Okay, additional spaces or additional tabs or line returns will cause an error in the script. So make sure that it's in this format here. Okay, so this one, right? And then connect it here. So this is what happens now. This is what the system happens. In production, either you enter the data manually and you have a web service input. So let's say you have a website that will input the data through a web service. And then from there, given your data set, it will remove the normalized losses. And then from there to apply transformations. So this one here is how it was transformed in our model. So it's practically teaching the system that based on this, the new data coming in, you apply the specific transformations. So in this case, we did a clean and then we did a normalize. So this element here is practically our model, trained model, telling the system that for new data coming in, this is what we should apply. So in this case, we remove the bore and the horsepower. In this case, we normalize everything using the Z transformation. Okay. And then from there, we scored it. So we scored it. So this is what we teach, what what the system has based on our previous training, and we score it. And then from there we execute a Python script just to change the name to sorry, what was the name again? Predicted price. Okay. And then from there we have the output. So what will happen here is after you've done this, you just click on this configure and submit. So you create a new experiment, for example, new production pipeline. Okay. Next, just this one, just keep as is, and then make sure your compute cluster is selected, and then review and submit. So from there, this will take around 7 minutes again. So I will not wait for that. So the result would be this one here. Sorry, should be this one here. Okay, in which based on these three data. So remember, we entered three data manually. So just for you to see again, what was the data? So this was the three data that we entered. And then from there, based on this three data, what is the actual result? So you will see here the actual result, which is three predicted prices. So so once you've done this, so this is a production inference already. You actually deploy it. You deploy it online. So from here, you click on deploy. So from here, I'll click on this deploy. Then I'll create a new deployment. So new production deployment. And I'll click on Azure Container Instance. So AKS compute is if you want to use this for real live production for huge processing. In our case, we're just going to be using the cheaper option because this AKS compute, I tried it, is going to cost you a lot. It will your $200 will be this for real live for many scenario computations. But for this one, we'll just go with Azure Container Instance. Then I'll click on deploy. So this one will take practically like 20 minutes. So in our lab exercise, you will stop here, no? But the actual result would be an endpoint that you have here. Okay. So this is what so this is the one that we created. It will and then from here it's going to try to create an endpoint that will take a lot of time. So the end result would be this one, wherein once you have this healthy deployment state, you can actually test your models. So in this case, okay, in our lab exercise, let's say that given the scenario here, okay, so given this scenario, so this is in this the input that they need. So you need to have your developer, or if you know how to create a website and you call this in what will happen is, okay, so given this input, this is the result. What you can do is you can consume it in two ways. So this one would be the API. So let's say you have a website that will call a REST endpoint. So this is the one, and then it also has the authentication keys. Or you can use it using Python, C Sharp, or R. So that's how you call for the service, no? So this the easiest for me. So I just create a website and then do a fetch to call this URL, and then I input I input these variables here in the body, and then I get a result, which is this one, no? Oh, sorry. Put this here. I have this result, no? Now, if you notice in this test, these are the three records that we initially put in our model, no? So that's why there's the default here. But in the future, so imagine that you have this one here. So let's say you have let's say you change this. So from 168, you make this 200, and then the width would be 50, let's say 74, and then number of cylinders would be, I don't know, let's just put there 6. I wonder what's going to be the effect. And then engine size would be 150. What would be the result? The price would be different, no? So apparently not. So I don't know how there's actually a way here to see in the model. So later, I'll show you how it will explain. No? It will explain from these models how these different columns would affect the price. Because what will happen here is that the system will tell you that for some columns, it does not affect the price no matter how much you change it. Okay, but for some, it's a huge effect in which it will affect the system, the price altogether. Okay, so I show you how to deploy it. So once it's healthy, then that's the time you can test it. So from here, you can enter your data and then test it. And then from there, how you consume it, I showed you earlier. You can use REST APIs or code to actually consume that data. All right. So let's do some lab exercises. Well, in the interest of time, I don't think we'll have time to do the lab exercise. So what I'll do is, if you go to this, if you go here, so you have this lab number 2. So you can do this at home after this session. So all the different steps that I showed you is here. So if you click on this, so it will actually go through all the steps for you. So this one again, I mentioned earlier, you created your machine learning workspace in lab number 1. And then from there, I showed you how to create a compute. So I'll share to you this recording for you to see how I did it online. So it's there in the recording. So we did all of these steps. I showed it to you. So we created the compute. We created a pipeline, if you recall. So we added the automobile price data. We did some transformations. So in this case, we selected the columns in the data set and we removed the normalized losses. So I showed that. And then from there, we cleaned the bore, stroke, and horsepower. And then from there, we normalized these data here. Okay. So what happens was, this was the result that we got. Okay. So automobile, select, clean, and normalize. And then afterwards, we created a training pipeline in which we split the rows. The rows, 70% would be for training. So this one here, and then so we did this as well. So I showed this to you. We trained and score. And then from there, we run the training pipeline. So this was the result. Then we evaluated the model. And then from there, we created an inference pipeline. We deployed it. And this was the result of the deployment. And then we deployed the service in which we tested it. So this practically the guides you through the process, but I will share also the recordings of this video. So if you want to see it, also to guide you once you do this exercise. So what are the additional differences with the different 3 machine learning scenarios that we have? So earlier we showed you what the difference between regression, classification, and clustering is. So as you know, um, the result is something that you know for regression classification, and then for clustering, it's unknown. Now for the algorithms, for regression, you have a lot of algorithms that you will choose. So if you go to the designer, so let's open the sample designer. So let's say you don't want linear regression. You want to choose other linear regression models. Uh, you have Poisson, decision forest, neural network, fast forest, and all of these now. So uh, you can just drag it and then from there remove this and then use this. Okay, and then just configure and submit, and then you're gonna practically have a different run altogether, no? So that's how the beauty of Azure machine learning is. With this drag and drop feature, I just remove this and then change it. And then for classification, you'll have different. So for classification, you have multi-class, so you can have this, you can use this adult census binary classification data set. And then from there, you can use So so binary. So you look for the binary. So two-class decision forest or two-class support vector. So all of these different algorithms you can use. And then for clustering, you have others as well. So one example would be k-means clustering. So I put in here these scenarios because in the lab, so you can do this at home. Once you've done the lab, there's the extra work. So you have your classification problem here. So you can click on this, and then from here, you'll see all the different steps for classification. This for clustering. I clicked on the clustering link. So what did I do? Okay. So yeah, for the clustering here, for the classification, you can click on this. So this for the classification, and then so so yeah, so these are the things that you'll be using for your exercises. And then you have different evaluation methods. No? So let's go quickly on these evaluation methods. So here in linear regression, you have all of these statistical values, which I'll not explain in this course. But what will happen here is that assuming you have this data set, you have the system, either you have this one. So imagine you have this line. Obviously, this line, if you have a model with this line, obviously it doesn't, it will not get you the result that you want. So you want to have a red line here that will accurately determine for you in the future what would be your result based on a specific set of variables. No? So obviously the red line is the best model. So this is what the Azure Machine Learning will try to get for you. This red line here. Okay, so this one, this green, this black, and then this blue line is not the model that you want. No? So this red line is what machine learning will compete for you. For classification, what you want is a black line because this green line here, if you have a model like this, what will happen here is that it will not. So let's just take out this line first. Okay. So with this green line, what will happen is if you have this model, there are some in the class A that it will not. It will say that it's under class B when it shouldn't be the case. For this one, for this row here, you have some class B data that will be part of class A. So you want to have a black line that will tell you that the data here is in class A and the data here is class B. So that's what exactly machine learning classification will tell you, this black line here. And then from here, in your research, there's a confusion matrix. So I'll not go to that because we don't have that much time, but it will tell you the area under the curve. So if your area under the curve is, let's say, 86%, it means that 86% of the time the system is accurate. So that's what it's practically telling you, for this area under the curve. So that's in linear regression, you practically look at R squared. So which we showed earlier, it's 91% of the time accurate in the case that we did. And then area under the curve for classification. And then for clustering, this is what happens, no? Uh, the system will try to determine. So initially, this is your data. The system will try to determine that this is the center, this is the center, and this is the center here. So that in the future, let's say in the future you have a new data point. Let's say this one. Let's put a data point here. So this data point, if it's here, then it will tell you that, oh, this data point is green. If it's here, this data point is red because it's nearest to this. And this data point is farthest from this green and blue. So it's nearest to this red. So it will classify it under red. If it's data, if this data is here, then it's blue. Now, if it's here in between, then that's where the issue will occur, and it will just find the nearest one. So in this case, it's nearest to blue. It will put it to blue. If it's here already, it's nearest to green. It will classify it as green. So that's how clustering happens, no? So in clustering, you have all of these data points, and then from there, it will try to determine the centers of each data point, and then from there, it will classify. Okay. So obviously, it's a lengthy process, but that's how clustering basically does it. Okay, cleaning up, no? So after you've done your exercises, because you have a lot more sessions to cover in the next few weeks, you need to delete your resources. Because for example, for this one here, you need to delete your resource. So in this case, how do you delete a resource? Just go to your compute. Okay, just go to your compute cluster, click on this, and then delete. You need to delete because if you don't delete, you're going to be charged by Azure even if you're not using it. Okay, so so for this one, I kept it for the whole week. I'm being charged for the whole week for this, but they're charging you 0.19 um, cents per hour, no? But again, no, since it's free, it's okay because you have a free account. But for me, for in a paid account, I'm already being charged for this, no? So you need to delete it, and then eventually, once you're done, you need to delete the resource group altogether because you need to. So for this one, so remember I created this my first resource group. So I click on it. So go to my resource group. Actually, if you go to home, you'll see your resource group that you created earlier. You just delete this whole thing. So delete resource group and then delete this and then delete. So you need to do that in order to stop paying for these services. No? So it's very important. So once you've done all these exercises and you're done, delete it so that you have money left for our remaining courses on machine vision and all of that. Okay. So now you'd probably ask me, okay, why is this all so complicated? This is all um, by the way, just before we continue, let me just do a screenshot here so that I can record the people that attended. Okay. Okay. So you'd probably ask, this also complicated, no? So here's the funny part. I introduce you first to the more complicated part so that you understand the basics, so that you understand how the things are working on the fly. But there's this Azure automated machine learning feature wherein you don't know any of this. You just give them the data and you practically let it solve for you. Okay. So with Azure automated machine learning, it does all the processing for you. You don't need to do all of those drag and drop. You just feed the data and then you say you compute it for me. um, sorry for this, but I had to go through the more extensive part for you to understand the basics on how it happens on the back end. And then for this one, this is where, quote unquote, the lazy and uneducated people just use it. No? So this is where the beauty happens. So with Azure Automated Machine Learning, okay, let's just go through it quickly. So you go here to your Machine Learning Studio. You have this automated machine learning. Okay. Now, let's create. So remember, if you recall earlier, so I uploaded this wine quality data that I had. So just for background, this is what it looks like again. So this is my data, no? So this is the data that they have. What I'll do is I want to create a model, okay? Because based on these values, I want to know the quality, okay? So I go to Azure Automated Machine Learning. I create a new job, and then from here, so let's say I'll upload the data for the first time. So you can upload, just follow these steps to upload this wine data that I had earlier. So this is the one that I had. Okay, I'll select that. So just upload the file. So this file here, just practically upload it online. Okay, and then from here, click next. So let's say um I'll create a new pipeline. So wine quality model. And then from here, I want to know the quality. Okay. And then I'll compete for my cluster. Sir, I'm going to select my cluster. So this one that I created. So good thing I did not delete all of them. Click on next. And then from here, I will choose. Okay, from here, classification, I will choose, oh, I want either I want regression or classification. For this case, for the wine quality, it's classification because if you look at it, it's classified under 6, under 5, under 7, under 8. Um, so yeah, you can do it that way, or it can be under linear regression as well because it's a number. So if it's linear regression, you'll get 5.5, 6.7, etc. No. So this one I chose classification, and then I'll click enable deep learning. So let's say you don't know it, okay, whatever. I'll just click on it anyway because I want to have deep learning. Sounds cool. And then from here, may additional settings. I showed you the primary metric. So let's say I want to, based on accuracy, but this one I want to have area under the curve. I want to click here, explain the best model, why you chose that model. I click on save. Then I click on next. So this one, very important again. So I want to have, so in this case, since we have 4,900 data sets, okay, so we have a lot of data sets. So I'll do is 20% will be validated, and then the remaining 80% will be for the training. And then from there, I click on finish. So we will not wait for the results for this because this will take 30 minutes to process. But this is why it takes 30 minutes. No? Um, so let me show you the result that happened. Where is it? Hold on a sec. Trying to see where. Uh, okay. So this is what happened. So this I ran this last night. It took me around 30 to 40 minutes. Okay. What will happen here is that it will provide you a summary, okay, of the best model that happened, and then from there it will give you all the different computations that it did. So you notice here it had a lot of algorithms. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It ran, actually, if you scroll down, it ran so many algorithms for you with different parameters. Because if you look at it, okay, let me just show you what happens here. When you go to, let's say in this example, so we're in a classification. So in this classification, let's say you use multi-class logistic. You have so many tolerances here, different weights. So you can run this many times, a humongous number of times, and you get different results, no? And then you'll get different, obviously different results and different uh, area under curve and different probabilities of success. So Azure Automated Machine Learning did it for you. It ran all of these um, for you to get the best result already. Okay. So in this case, let's look for wine computation. Okay, I'm gonna see this. Okay, so this is the one that we're running right now. Where's the one that I ran last night? Okay. So in this case here, so this was the result in my automated machine learning that they had, and this was the best one that they gave. And it says here that it's 85% successful. That's the accuracy of the model. And then from there, these are the different models that it ran for you. So many. So I will not go into that. And let's say view explanation why this is the best. So from here, it will tell you that in this scenario, alcohol, free sulfur dioxide, volatile acidity, and density had the most importance in the data set. Okay, so top 4 features by their importance. So you can explore all of these colorful graphs if you're a statistician. But so yeah, no. So that's how it did it for you. So apologize for if we did all of these for you to understand how it goes on the basics, but this is where the magic happened. It ran all the different scenarios for you. for you to get the best possible result. No, so that's automated machine learning. Okay. Okay. So to wrap up, so uh, I'll probably for those who want to ask questions, I'll for the remaining 10 minutes of the course, I'll have you can feel free to ask any questions. But to wrap up, um, we introduced you to Azure AI introduction. So different features of AI that Azure covers. So actually, AI is a broad concept. Machine learning is just one of them. ChatGPT is another. So if you look at it, ChatGPT is under language, which is part of the text feature. So if you look at it in ChatGPT, if you go back to the very first slide, ChatGPT is under language. Okay, so that's where ChatGPT comes into play. So actually, I forgot to put here OpenAI because uh, Microsoft invested in ChatGPT in the company. So if you want to have your private ChatGPT for enterprise companies, there's also a service for that. Okay, so Microsoft is one of the, in fact, probably the only one because Microsoft is the one that invested in OpenAI. So you have that feature available for you in Azure. So we discussed Azure AI. We discussed what supervised and unsupervised machine learning is. So again, supervised is if you know the result. Unsupervised, you don't know the result. And then we discussed how linear regression, classification, and clustering is. Then I showed you an exercise on how you create the account and the workspace. And then from there, the exercise on linear regression. And then I introduced you to automated machine learning. So for the next steps, let me just put here the linear regression for you to learn more. So we have all of these in the lab. So I shared this link to you on all of these exercises you can go through. So this is more than enough for you to get immersed on all of these three, plus the automated machine learning. And then from there, even I gave you an additional sheet on wine quality data if you want to do that. And then from there, yeah. So next week we'll be discussing computer vision. No, so there's a lot more topics to cover in AI. But thank you very much for your time for attending. If you have any questions, feel free to ask me in the chat below. Any questions? So let me since we are a few, if you want to speak, let me enable your what do you call this? Let me enable your microphone. No questions, just information overload. So yeah, it's a lot to cover. In fact, we can actually do this for the whole the whole day actually. In fact, if you have any organization that you want me to provide this course for the whole day, feel free to do let me know. I can provide it for free. So this is so yeah, I can do it also if you have a company or organization that you want me to provide this because obviously it's a lot to cover for 2 hours. So allow okay.
Hello po. Good
Hello,
afternoon po.
yes. Yes, good afternoon.
If magpapa-schedule po ba kami ng ano, ng ganiyang seminar sa ano, ako under pala ako ng PhilHealth. So, if magpapa-schedule pa kami ng ano, paano yung process or kanino kami puwedeng
Ah,
sa inyo na lang?
yeah, just kay Alan De Villa. So yeah, I'm in touch with Ma'am Jovita Aragon as well, and with Alan De Villa. So,
Okey
but
po.
yeah, you can send me a message in LinkedIn as well, and I can schedule it.
Medyo na-late din kasi ako nung dating kanina dahil
Ah,
na-miss ko yung first 1 hour, eh, ano.
okay, no problem.
Oo,
Sige.
sige
Yeah,
po.
if you have around 15 participants, then that would be great. I can go to your office.
Mukhang kaya naman po. May ano naman po, eh,
Sige.
bale hiwalay yung sa main office, puwede rin hiwalay yung mga iba't ibang ano, region sa ano, puwede
Oh,
namin
pag gano'n, we can do it online pag gano'n.
opo.
Okay. Sige. Sure. So give me a message, Nelson, sa LinkedIn. Are you part of the Azure group na, no? Azure AI group?
Ah, hmm, hindi pa po. Kaya yun nga po medyo ano, para may mas
Okay,
makapag-ano, explore.
I'll send you my email here.
Sige po.
Okay. Okay, if there's nothing else, I will guys let you go for 10 minutes in advance. And thank you very much for attending. We have a few more weeks to cover, a few more topics to cover for you to get certified on AI 900. So this is our very first session. And thank you very much for attending. So I'll be sending also the video after this meeting for you to play again the session. So, okay. All right. Thank you very much and see you in the next few sessions. Okay, goodbye.